In this video from ITFreeTraining, I will be looking more into how to subnet. In previous videos, I covered the basics of subnetting. In this video, I will look at subnetting in more detail. So let's get started. To start with, I will look at the following IP address. Given this address, the administrator has been asked to break it up into 5 different networks. To do this, I will look at my power of 2 table. The next step is to work out how many bits are required to provide 5 networks. Looking at the power of 2 table, this would be 2 to the power of 3. This gives 8 networks in total. Unfortunately, 2 to the power of 2 only gives 4 networks, so the next option is 2 to the power of 3. This does mean that there will be 3 more networks than required. However, it also does give some room to expand if required. Before I look at how to perform these steps manually, I will first look at how to perform these steps using an online subnet calculator. Online calculators take a lot of work out of the subnetting process. However, if you are planning to attempt a certification exam, in particular the Cisco exams, it is a good idea to have an understanding of how to do the process manually, since you won't have access to the online IP calculator during the exam. First of all, I will open the Start menu and then select Internet Explorer. Once open, I will go to the web page with the online calculator on it. I have placed the link for the website in the description of the video if you have trouble finding it. There are many online IP calculators which have more options than this one. This one is quite simple in contrast. However, as we will see in a moment, it has one great feature that many others do not have. To use the tool, I will scroll down and enter in the address from the example. The next option is the number of bits in the subnet mask. For this, I will leave it on the default of 24, which was the subnet mask given in the example. The next option is Move To. This is the feature I was talking about before, and you don't see it too often. In the example, 5 new networks were required. According to the powers of 2 table, this will require 3 bits and thus will create 8 networks. More than required, but 2 bits will not be enough. This means that I will need to enter in a value of 24 plus 3, which is 27. Now that the values have been entered in, I will press the Calculate button. The subnets will now be calculated. At the top is a breakdown of the original address. This gives a lot of useful information. In particular, notice at the bottom the original network has 254 hosts per network. If I now scroll down, the 8 subnets are shown. You can see at the top a breakdown of the first subnet. The breakdown contains a lot of information in regards to the subnet. For example, shown here is the network address. You can see that it is using 27 bits for the subnet mask. Below this, notice that the broadcast address is shown. Notice also on the right-hand side the binary for the IP address. All the bits in the host ID part are all ones. Communication with this IP address will send data to all devices on that subnet. Keep in mind that for security reasons, routers generally by default will not route broadcasts between networks. Notice the last line of the breakdown for this subnet gives the number of hosts that can be used for that subnet. This was 254 when there was 1 network. Now that it has been subnetted into 8 parts, it is down to 30 hosts per subnet. On the far right in the binary data, notice the binary data highlighted simply increases the value from 0 to 7, giving a total of 8 subnets when you count from 0. When the subnets line up with 8 bits, the math is easy. It is just a matter of working out the decimal value. In this case, the last octet in the IP address has 3 bits for the network and 5 bits for the host. This makes the math a little more complicated. If I scroll down to the bottom, notice the number of subnets and hosts are listed. The hosts has dropped from 254 to 240. This is because hosts are lost due to them being required for broadcasts and network addresses. This should give you the basic idea of how subnetting works when you use an online IP calculator. I will now have a look at how you would do the process manually. To demonstrate how to subnet manually, I will use the same example as before. However, this time I will divide the network in 4 separate networks. To start with, I will need to work out how many bits I will need to use in order to create 4 networks. To do this, I will look at the power of 2 table. Since I require 4 networks, I will need 2 bits, since 2 to the power of 2 gives us 4. This is good because there is no wasted subnets. I will now have a look at how the address can be broken down into subnets. To do this, take the address you want to break down into subnets and change it to binary. Once in binary, it is easy to break the address down into different sections. The first 24 bits of the original address have already been allocated, so the first 24 bits will be the network ID. After this, 2 bits have been allocated to the subnet ID since 4 networks were required. The last 6 bits of the address will be allocated to hosts. Most of the network ID has been allocated already. For this reason, when the 4 new networks are worked out, they will have the same bits from the original address as shown. So essentially, the first 24 bits are copy and paste from the original address. The next part that I will work out is the subnet ID. For the first network, this will be 0 in binary, which is 00. For the rest of the networks, it is just a matter of adding 1 each time. So the next network will be 1, which is 01 in binary. The next network will be 2, which is 10 in binary. Adding 1 again will give us the last network, which is 2 in decimal and 11 in binary. You can see that the process is quite simple to work out the subnet ID. The last part is the host ID. This can range from all bits 0 to all bits 1. All the hard work is done. I will now have a closer look at each network. First of all, I will look at the first subnet. To calculate the network ID for the first subnet, I will copy and paste the binary values for the first 24 bits. Since this is the first subnet, the subnet ID will be 0. The last 6 bits of the address will be all zeros. The network ID always will have the host ID part of the address all zeros. Now that the address has been worked out in binary, it is a matter of converting this to 4 decimal octets. This is the networking ID. It can be assigned to a host. Generally, this would be used in routing tables or network diagrams. Next, I will look at the broadcast address. Like before, copy and paste the first 24 bits. In fact, all the addresses that I will look at start the same, so I will copy and paste them all in one go. Next is the subnet ID. Since all the addresses I am looking at are in the same subnet, this will not change, so I will also copy and paste this. The last part of the address is the broadcast address. The broadcast address always has the host ID as all ones. The broadcast address has been worked out in binary. It is now a matter to convert it to octets. Each subnet will have a network and a broadcast address that are not usable for hosts. I will now look at the first host address that is usable. To work out addresses, simply set the host ID to 1. Once this has been worked out, change this binary value to octets. The next step is to work out the last IP address that is usable by hosts. This will be all the bits on except for the first bit. Remember that all bits on would be the broadcast address. Like before, the binary value is changed to a 4 decimal octet. There you have it, the main addresses for the first subnet. So let's have a look at the second subnet. Since the first 24 bits are the same, I will copy and paste the 24 bits from the previous network. Now there's the subnet ID. Since the last subnet was 0, the next subnet ID will be 1. All addresses in the second subnet will have the same subnet ID, so I will copy and paste this to all addresses. Next, like before, for the network ID, I will set the host ID to all zeros. The next step is to work out the broadcast ID. To do this, I will set the host ID to all ones. The next step is to work out the first usable IP address on this network. This will be done by setting the host ID to 1. Lastly, the last usable IP address is worked out by setting all the host ID bits to 1 except for the first one. You can see that even having to configure it in binary, if you break the addresses down in bits, the process is quite easy. I will now have a look at the third subnet. Like before, I will copy and paste the first 24 bits. For the subnet ID, I will use the value 2, which is 1, 0 in binary for all the different addresses. To work out the network ID, I will set all the host ID bits to 0. For the broadcast address, I will set all the host ID bits to 1. For the first address, I will set the host ID to 1. For the last address, I will set the host ID to all the bits on except for the first one. You should get the idea of the process, so I won't worry about going through the fourth subnet. You can see in the fourth subnet, the subnet ID will be 3, which is 1, 1 in binary. In this video, I have looked at the process of subnetting using an online calculator and manually. It is important to understand the fundamentals of subnetting to help you troubleshoot problems. That's it for subnetting. I hope you've enjoyed this video from ITFreeTraining, and I hope to see you in other videos from us. Until next time, thanks for watching.